talk to you about Homecooked software and Barefoot developers. It's local first tangential, but I promise it will become relevant. First, a very quick intro. My name is Maggie. I look like this on the internet. I'm a product designer at a startup called Elicit. We are working on using language models to help scientists and researchers pull reliable data out of long research papers. I'm also a mediocre developer, which means I try to build things, and it usually doesn't work. And then I also write about and research a lot of things in public online, including tools for thought, language model interfaces, and end-user programming, and I will touch on some of these today. So I'm here to convince you of two things. First, that language models are going to create a golden age of local home-cooked software and Barefoot developers. And second, I want to convince you that the local-first community has a significant role to play in building this future golden age. So here's what we're going to talk about. First, local first beyond local data. Home-cooked software versus industrial software. My pitch for Barefoot developers. Why language model Legos need glue. And lastly, how we can bake local first into everything by default. So let's talk about local first beyond local data. I know everyone here knows what local first is about, but for people who might be watching who don't know, I would just want to do a quick definition. So when we talk about local first, we're primarily talking about where data lives and how it syncs to our devices, right? In the old school world, we had everything on one big machine, and there was no cloud, and there was no data synchronization, except if you threw a LAN party, you were pretty much on your own on your computer. We then moved into the world of the cloud era, right, where all our programs and all the data lives in the cloud, and then it streams to our devices when we're connected to the internet. And everyone here is trying to make this future happen, where we have this local first, where all the software and the data lives on our local machines, and then it just uses the cloud to sync between them whenever we get internet access. So the existing philosophy of local first is fantastic, right? I'm on board, you're on board. But we come to, I think we should try to expand our minds a bit to imagine a more holistic vision for local software that's about more than just databases. So local, traditionally, means something that is close to your home. It means something familiar, intimate, and trusted by you. It means something unique to its location, and it can also mean something community-oriented, as in supporting your local businesses. So there's an interpretation of local software that means software that is built close to the home that serves the needs of the home. It's software that someone might build for themselves, for their family and friends, and for their community and neighborhoods. It solves local problems for local people. Now, this idea has been floating around with various names attached to it for roughly 20 years. Clay Shirky first proposed the concept of situated software in 2004. He defined this as software designed in and for a particular social situation or context. And he painted a vision of applications that could be used by dozens of users rather than thousands or millions. This was an absurd target population, both then and now. That dream was that communities would get form-fit tools for their particular needs rather than trying to adapt generic software to solve them. Unfortunately, Shirky was very far ahead of his time. This was practically impossible to build this small-scale software in 2004 and barely possible now. Now, 16 years later, in 2020, Robin Sloan published this blog post called "An App Can Be a Home-Cooked Meal," which picked up on many of the same themes. He talked about building a tiny app for his family to send short videos to one another. Only his family have access to it. He's not going to turn it into a startup, and it doesn't have any commercial or market value. He made it out of care and love for the people around him to help them solve a small problem and have enjoyable experiences together, just like he would if he had made them a home-cooked meal. So home-cooked apps, like meals, are apps you make for the people you know and love. We've progressed enough since 2004 that someone can make one of these, especially if they're simple. They are usually cheap or free to run. You're not at the mercy of a corporate pricing strategy. You can control what happens to them. You can control what features are added or removed and whether it gets sunset on its beautiful journey. They're private. They won't sell your data unless you do it yourself. They serve your specific needs. There's no financial pressure to monetize them or make profit from them. They are safe. There's very little risk of nefarious actors or misaligned incentives, and they are made with love and care. I like collecting examples of these. So this was one that someone made to track their newborn's breastfeeding and diaper changes. I don't know why you would need to put this on someone else's cloud server. Here's a fun one for reconciling personal finances that someone described as a mashup between Superhuman and Tinder, which sounds much better than most financial software. This one's cool. This is a live sales dashboard that someone made with an old iPhone, which is a nice way to reuse hardware. And this is one that someone made for their diabetic partner because the default interface on their glucose monitor wasn't giving them the critical information they needed to stay alive. So they took matters into their own hands and made one that did. I think it's very fitting that all of these examples of home-cooked software usually deal with the kind of data that you don't want leaving your personal home, like your bodily functions and your children and your finances. So Robin Sloan's post on home-cooked apps really hit a nerve. It's been wildly popular in the programming community and passed around endlessly. And I think this is because it pointed to many of the tensions we have about the way that software is currently built. These small-scale personal apps are drastically different from the kind of software that most of us use every day, which is professionally made software. This is like a meal or a cake made by a professional chef at a restaurant. It is definitely more delicious than yours, but it's also more complex, and it's much more expensive to make. It requires many people with special expertise. You can't control how it's built, or how long it lives, or how much butter they put in it. It has commercial interests at heart rather than familial love and care, and there's less security and privacy because you don't know where your data is going or what machine learning model it's going to be trained on. And professional software is the kind of software that almost everyone in the world uses. It's made for masses of people at a global scale by huge corporations. At the moment, I think we're in the industrial, high modernism age of software, where these standardized, one-size-fits-all apps are made for us by people who don't know that much about us. They are primarily working for large Californian companies and shipping their software overseas. They're sitting in San Francisco trying to understand our problems and pains over Zoom calls and customer support tickets. But they have so little context on our lives, what problems we need solved and what we value. How could an American getting paid 6 figures and sitting in Mountain View really understand how to identify problems and design solutions for a homemaker in Tokyo, a street seller in Turkey, or a doctor in Tunisia? For the most part, they don't, or if they try, they do it badly, and they instead design software that solves their problems, like Uber and DoorDash. So my friend Casey Climbs wrote a fantastic piece on the design dynamics of large-scale software after working on Google Maps for years. He pointed out that our current approach is designed to only solve the most common needs for the highest number of users. Anything beyond that is what we call the long tail of user needs. These are things that only a few people need, but there's a nearly infinite amount of them. So in the case of Google Maps, the long tail of user needs is anything beyond, how do I get from here to there? Google Maps is never going to support showing historical boundaries or tidal patterns, even if those things are essential to a few dozen or even a few hundred people. In the current system, this stuff is always considered out of scope, right? PMs will tell you this all the time, because it doesn't make any financial sense to support that long tail. Industrial software can only target the biggest problems for the most people, and these are ideally wealthy people with disposable income. This is an economic limitation, right? Building features that solve every single long-tail need requires a lot of engineering labor. And engineers are very expensive. For industrial software, you need large teams of developers and designers and product people who demand high salaries in exchange for their valuable hard-won expertise. And the way that we fund this is primarily through US-based venture capital funding, which demands hockey stick growth in return. All the focus goes into making hundreds of millions, or ideally billions of dollars in profit to pay back the investors. As a member of a team that's in the middle of doing this, I can say that it affects every single decision about how we build the software and what features are prioritized. I've drawn a little map to help make these dynamics clear. So we have scale on the horizontal axis, going from small special snowflake software to global industrial software, and profit on the vertical axis, going from unicorn billions to sinkholes. So most software today sits in this upper right-hand quadrant. It aims to make as much money as possible with the largest number of users. Anything that falls below that profit line ends up being a short-lived failure. It is not allowed to survive long in the marketplace. But over here on this left-hand side of small-scale specific Snowflake software, we have the land of opportunity. This kind of software does not need to make that much of a profit. It just has to operate at a very low cost, although maybe it could make some medium profit in the long term. But this land of opportunity has a skill issue, because the Venn diagram of people with the skills to make home-cooked software and professional developers is a concentric circle. All the examples of home-cooked software I showed were made by people who work as professional developers. The vast majority of people who might want to make a piece of home-cooked software can't because software development is too complex. Even those of us who are professionals don't always have the right knowledge to make a full-stack app for ourselves. This isn't news to anyone, right? This has been the main complaint of end-user programming advocates for decades. So widespread, local, home-cooked software is still just a pipe dream. This is a shame because we know the world is full of problems to be solved. And while not all of those problems have software-shaped solutions, a whole bunch of them do. It is hard to argue it wouldn't be overwhelmingly net good for more people to be capable of designing and building their own software to solve problems for local people. But what happens if some parts of the software development process suddenly get faster, easier, and cheaper? Well, 6 years ago, OpenAI released GPT-3, which was the first large language model. And since then, we've all been on a bit of a ride. Now, when I say large language model, I'm talking about what everyone else calls AI. And I think that term is far too broad. So I just want to be specific when I say I am talking about models that are made using deep learning and neural networks. These are primarily large language models, but also includes vision and action models. So these are models that can understand words, code syntax, images, and interface actions based on human training data. I'm also going to be talking about what's called agents. So this is when you get a large language model to behave like an agent that can make plans and decisions and try to achieve the goals that you give them. We then give these agents access to external tools like web search, calculators, calendars, and the ability to read and write code, as well as long-term memory stores and databases. And then we get them to mimic logical thought patterns, like having them observe what they know and plan what they want to do next, having them critique their own work, or having them think step by step. This improves their performance a lot, and then we let the agent decide what tool it wants to use at any one point to solve the problem that we've given it. So this architecture of chaining together logic and tools with language models actually makes them far more capable than they would be otherwise. And they end up being able to do quite sophisticated tasks within our existing programming environments. So unless anyone here has been living under a rock, you know that we've been deploying language models and agents into tools designed to help professional developers, right? Copilot, Replit, Cursor. They can read and write code, they can debug things, they can create documentation and write tests. One study showed that developers using Copilot were 55% faster than those without, so we at least know this speeds people up. I can say from personal experience, I am a much more capable engineer with these tools in my hands, but I also appreciate that there's a lot of skepticism and controversy around them. It's possible they're just creating more crap code that everyone's going to have to debug down the line. But I actually don't want to talk about how advances in AI will affect professional developers, because with all due respect, we have it pretty good, we're boring. I want to talk about a different kind of developer. These are what I call barefoot developers. So this is a term I've made up, and it's based on the idea of barefoot doctors. So barefoot doctors were an initiative by Mao's government in China in the 1960s. Not saying everything Mao did was good. I'm just saying this program that I'm sure he had nothing to do with was actually quite successful. So at the time, 80% of the population lived in rural areas and had no or very poor access to healthcare, because all the medical expertise was concentrated in urban areas. So they selected people from rural villages and trained them up to become healthcare providers for their communities. These villagers were taught preventative care, curing simple ailments, diagnoses, and giving vaccines. And then these people would return to their home villages to serve the people they knew. They were still barefoot peasants like everyone else, but now with more skills. So this program was a wild success. By the mid-1970s, there were over 1.5 million barefoot developers working in China's villages, and life expectancy over that period rose from 35 years to 63 years. So the developer version is not going to be organized by a central government or dictator. It only exists in very limited ways at the moment. To explain this, I think we just need to talk about the scale of people interested in programming. So on one side, we have regular end users over here. Now, in theory, I am a big proponent of end-user programming, but I have to admit that most of these people do not give a shit about programming. Okay? They don't want to learn it, and I think we need to stop harassing like normal nurses and teachers and therapists to learn to code. So anyway, it's not about end users. It's also not about professional developers on the other side, because we all love writing code for its own sake, right? We will invent excuses to program things. But Barefoot developers are the people who live in this middle bit. At the moment, these people are like teachers who make elaborate Notion spreadsheets for managing classes, or students who make over-the-top personal dashboards, or financial planning wonks who produce extensive spreadsheets. They are people who are technically savvy and interested in solving problems for themselves and the people around them, but they don't want to become fully fledged programmers. They still live within the world of end-user-facing applications, right? They rely a lot on low and no-code tools, but they do wildly complex things with them, just pushing them to their limits. And they are the kind of people who I think would be thrilled to have more agency and power over computers. But they never make it over what I call the command wall line. They never end up in the terminal, because that is a huge jump in complexity and usability and frustration from using something like Airtable or Notion. This means most of their work is held hostage in the cloud and requires them to pay monthly subscription fees to access it, which is not something developers have to deal with. They have far less agency and power over their creations than full-blown developers. But I have this dream for Barefoot developers that is like the Barefoot doctor. These people are deeply embedded in their communities, so they understand the needs and problems of the people around them, and they are perfectly placed to solve local problems. If given access to the right training and tools, they could provide the equivalent of basic healthcare, but instead it's basic software care. They could become an unofficial, distributed, emergent public service. They could build software solutions that no industrial software company would ever build, because there's not enough market value and they don't understand the problem space well enough. This is the long tail of user needs. And these people are the ones for whom our new language model capabilities get very interesting. So, what can language models do for Barefoot developers? This is a now infamous tweet by one of OpenAI's co-founders, Andrej Karpathy, claiming that the hottest new programming language is English. What he meant by this is that these models can accept natural language input in the form of descriptions of interfaces and software functionality and output working code. We are still in the very early days of this, but there's already a few prototypes out in the wild that show what's becoming possible. So this is Vercel's V0. It generates working interfaces based off text descriptions of what you want. So I've told it here to make me a personal finance dashboard, and I added some details, like I want some feature cards showing me daily purchases and my recent transactions and my income over the last couple months. It's obviously making up dummy data here, but it's producing a pretty usable interface. It's given me 3 versions to pick from, which is quite nice, and I can now type in follow-up text, which is being blocked by the recorder, telling it how I want this to change. So I told it to add an accounts and bills section to the sidebar, and it correctly did that. I've sped this up a bit, but otherwise, this is pretty real time once it goes over the initial loading. You can also see it's produced working code. I can actually go inspect this. I can edit it. It's React. It's Tailwind. I can also select individual elements in the interface and then tell it how I want those to change. So I have quite a good feedback loop going here and fine-grained control over this interface. It's, of course, not hooked up to a back-end, but this is a pretty interesting solution for generating front ends. Another good example is TL Drawer, some of whom are here. I'm lucky enough to get to hang out with them sometimes, but unbiasedly, I think they're doing some of the most interesting work in generative interfaces. The odd thing is they're nominally just building whiteboarding software, but they hooked up GPT-4 Omni, which is a multimodal language model, to their canvas so that you can draw any interface you like in their whiteboard, and then you click this Make Real button in the corner, and it makes what you told it to do. So here they've said, I want like a coffee brew calculator, and they've used red text to annotate and point to things of how details should work. This is all kind of straightforward buttons and inputs, right? But after a short while, you get a working interface with all the elements that you defined. And it works. This is pretty cool. This next one is also by TL Drawer. But this one's crazy. So Steve, somewhere, it was just like, okay, I want a photo booth app. Like, I'm just going to draw what I want, and I'm going to annotate it, and then you're just going to make me this. And he said he didn't write any custom code for this. It just understood what to do. It has enough training data of software it's built previously that this works. And because it's a whiteboard, you can infinitely iterate. You can select your previous prototype, sketch a new thing, tell it to make real, go on a little loop. It's pretty crazy. I want to say this tool is online. You can go use it. I think if you're someone who's skeptical about the capabilities of language models and you don't have a good intuition for what's possible and what's not, spending time playing with this will update you a lot. This all feels exceptionally promising for the future of local home-cooked software. Because we have to remember that the stuff Barefoot developers need to build is not as complex as the professional software that we are all used to working on, right? They do not need to scale up to millions of people. They do not need to juggle conflicting user needs or pivot their business. They do not need to ship lots of features very fast to make a high return for venture capitalists. Most of this software that local communities need could probably be solved with some simple CRUD apps, persisting data over time, with some user authentication and a few API calls, and ideally multiplayer. So as much as I expect the number of professional software developers to grow in the coming years, I expect the number of Barefoot developers to grow exponentially more. But to get to that world of millions of Barefoot developers, we have some problems to work through in the current moment. And the way I'm going to put this is that language model Legos need glue. So language models are very good at giving you a bunch of disconnected Lego pieces at the moment, right? They can make pretty interface elements for you, they can manage state for you, they can make API calls, they can write basic logic, but they don't tell you how to stick all these things together into a working application. Meanwhile, you want a cool castle. And it's very unclear how you are supposed to make a castle from these disconnected Lego pieces. At the moment, you still need the knowledge of a professional developer to glue them together. If you generate something with Vercel's v0 or TLDraw, you still have no idea how you might deploy that to a particular domain or a device. You don't know how to persist data by setting up a database. You probably don't even know what a database is. You have no idea how to add multiplayer collaboration. You don't know how to have multiple users log on and have different editing permissions, and like 99 others that I haven't thought of, but Hacker News will tell me later. We're missing the glue that brings all of these pieces together into working software, and I think the glue is going to come in two forms. First, I think we're going to get language model agents that are designed to act as central orchestrators for home-cooked software projects. So these agents will guide Barefoot developers through the process of writing technical specifications and helping them work out what kind of tools they might need for a given piece of software. And I think we're also going to get tools that are designed to talk to and work with these orchestration agents. I expect these agents will have a set of default tools that they've been taught how to use and call on these whenever their human needs to build some new software. These might be APIs to multiplayer infrastructure, they might be database managers and deployment pipelines. Which brings me back to the topic, near and dear to all of our hearts, local first. If I'm at all right about there being a sudden explosion of local home-cooked software, how does this affect the strategy of the local first movement? How would you try and make sure local first is baked into this future by default? Because this default tool set for Barefoot developers shouldn't it really have a database that's a local first database? And once that app is deployed, wouldn't it be nice if it worked offline? Barefoot developers might not know to ask for these things in their technical specs or prompts. Whatever defaults are baked into these agents and their available tools are going to make a lot of decisions for them. If you are currently building a local first tool or a database, you should consider what kinds of interfaces would make it accessible to Barefoot developers and their future agents. Can someone prompt their way into a local first setup in plain English? Could they write a technical specification in Markdown and end up with a working database? Could you develop your own small language model that guides someone through using your tool? Frankly, can you stick TLDraw onto the front of your system and start letting people build full-stack apps with it? To give you some motivation, I want you to imagine a future where we do get this explosion of local home-cooked software, but it's not local first. So we get powerful, flexible tools that let Barefoot developers make lots and lots and lots of local home-cooked software. They solve all kinds of specific local problems for the people around them, and their communities love it, right? And they all become dependent on everything that they've built. But then the software and the data is all held in the cloud, and you have to keep paying a monthly subscription fee to access it. And then suddenly the terms of service change, and there's a giant advertisement in the middle of every homepage. And then the subscription fee doubles. And then it turns out that what they built was never actually theirs all along. I expect that would be a super lucrative business model. So I think you should care about this because the local first movement and the local home-cooked software vision are distinct but philosophically aligned. They're built on the same foundational values that users should have agency and ownership over their data and software. At the moment, this community is focused on solving hard technical problems, but you should keep an eye on what's developing around you as the software-making process rapidly becomes more accessible and democratized. We can weave the local and local-first philosophies together and build tools that serve both of them. I really want local-first to be the default choice for local software. The alternative feels unquestionably worse. The amount these two visions overlap and complement each other is up to everyone in this community to decide. I want to end this with a quote by Ivan Illich, who I'm sure some of you will have heard of. He wrote a wonderful book called Tools for Conviviality, where he talked about the importance of people being able to make tools for themselves. He says, people need not only to obtain things, they need above all the freedom to make things among which they can live, give shape to them according to their own tastes, and to put them to use in caring for and about others. I think software is no exception to this. So that is the end of my talk. Thank you very much for listening. I want to say this was a bit of a challenging talk to write because it's the first time I've done it, and I had to try to make some very big claims and then back them up. So I would really love constructive criticism about the places you think that I'm wrong or that I've overlooked important details. I just ask that you be kind about it and not like hacker newsy about it. Thanks. Thank you very much.